Hello, Mickey.
正在调。
Okay. So actually, hello, Mickey. Do we need to restart? Okay.
So,
Okay. 刚刚一开始
all the information before is not.
Okay, so actually, the special design of V40 is very impressive to our audience. And could you tell us why you have come up with this idea to do the bicopter drone?
Yeah, actually, from the very beginning, we started to realize that the quadcopter has its limitation. The quadcopter is the most stable setup that we have. Has its limitations. The quadcopter is the most stable about it, but at the same time, I think the quadcopter is definitely not
cannot be folded.
Yeah, definitely not the most efficient drone setup.
Yeah.
And we saw other airplane setup like V-22, which is bicopter, and the Chinook. They are using this kind of bicopter setup. We started to ask us why we not doing the
Also to the
bicopter. Why don't we cut off two propeller, and we want to see what will happen? Yeah. So I think this is the starting point of why we started to develop this kind of setup.
Okay, so do you have you met some challenges, like what kind of biggest difficulties during the process you doing the design?
Yes, I think the V-shape bicopter is a very tricky setup. The most obvious one is that the control is very sensitive to the setup. I mean, you have to notice that the V40 is a V shape, and the V, how deep the V is, the tip of the V and the bottom point of the V, it means that the propeller is on the top, and there is a distance between the propeller and the center of mass of the drone, and those parameters are very sensitive, and it needs to be designed just right to make sure that the bicopter can be controlled no matter what speed they are flying. Yeah. Okay. So this is the biggest challenge that we have met before, because we have to address our control algorithm to make sure that the drone can be controlled and doesn't do any.
Autonomously.
Yeah, autonomously.
So if you have any questions, please feel free to answer in our comment area. And could you share with us what kind of biggest advantages of V40 when it do operation in the agriculture in the field?
Okay, so V40, as I just mentioned, that it is designed based on one word, efficiency. So how comes why it is the most efficiency drone that we have ever designed? I think it started with the propeller size. So I better have pictured it.
You can draw?
I can picture it.
Could you give us a close-up of this boat? I guess it.
Oh, this one also? Yeah.
Yeah.
So
Can you see there all the audience?
yeah.
Okay. Very well.
I think if we are considering design a drone with the limited area, propeller area, let's say A. So if we design a bicopter setup, the area of each propeller will be A divided by 2. Oh. A divided by 2, yeah. And if we design this drone with a quadcopter setup, we have to draw a little bit smaller, probably smaller circles. And the area will be, A divided by 4. So you can clearly notice that the size of the propeller is different. So in bicopter setup, the size of propeller is bigger. And why it brings more efficiency for the drone is because in aerodynamic theory, the bigger propeller will have a slow airflow down the propeller, and the slower that the air flows down the propeller, it gives more efficiency and more lift for the propeller. So
if we have the bigger airflow,
yeah,
we will have
the slower airflow, but the flow area is bigger, but the flow rate, the flow speed is slower.
Okay.
And once this flow speed is slower, the propeller will have more efficiency
will be
than
faster.
this one. So we designed this with the limitation that the total area is the same, but for this we have more efficiency because the flow rate is slower down the propeller.
Yeah. So have you guys clear about this comparison of with bicopter and the traditional one?
Yeah.
So if yes, we will continue.
So this is only for the efficiency, and for the operation side, why it has another advantage? Because the flow down the propeller will be like this. The air travels like in this route, and this is the propeller itself. And the bicopter setup will have a much wider airflow down the propeller. And you have to notice that the V40, the spray nozzle of V40 is right down the propeller.
Yeah.
At
right
the center.
down,
Yeah.
and it's as strong.
Yeah. The particles, the spray drops, is traveled by the fact of the airflow. That's right. So in bicopter setup, we have a much bigger and wider airflow down this, so it gives a wider spray area, and a wider spray area definitely gives more
efficiency.
the work efficiency.
Yeah.
And in another word, if we do another simple math, if we design a 50 kilogram drone, 50 kilogram total weight, if it's a bicopter, so it will be 25 kilogram per each propeller. The lift that needs to be provided.
25 kilogram.
Yeah.
Can you see the number?
25 kilogram. But if it's a quadcopter, it will be divided by 4, right? So it's 12.5 kilogram.
Much less than the bicopter.
Yeah, you have to see that the propeller that provides less thrust in quadcopter setup.
Yes.
That means the airflow or the airflow rate or the airflow area is much smaller than the bicopter setup. This is why bicopter is efficiency. While in the real operation, it gives a much wider spray area. Thus, it boosts the work efficiency.
Yes. Yeah, it will be more efficient. So
is it clear?
Can you see the details of the numbers? I will show it like that. And can we change to the main camera? So thank you, Tian Hao, for sharing us the calculation of the compare and the contrast of the V14, the bicopter one and the traditional one. So Mickey, can we see the kind of video of V40, and let's see the airflow of V40 in real operation. Please wait for a minute.
It is very wide, the airflow.
Yeah, we can see the airflow just now.
It is just as what I drove before, but it's,
so after we have know about the design of V40, let's come to the P40. Do you have any questions now?
P100?
P100, right,
P100,
sorry.
yeah.
The biggest start point of P100 is, can you share the biggest advantages of P100?
Okay, I believe that the drone itself, P100, is always the first, the most clear advantage of this series because of how heavy duty it is. I mean, it's 100 kilogram weight level, so we can't even imagine of that we have developed into this kind of heavy duty drone. Actually, in the beginning, when SIG first started developing the drone, it's only 15 kilogram, and we thought
15.
It's pretty heavy. Yeah, it's 15 kilogram, but we thought already. Yes, we thought it already heavy enough for customers, but to our surprise, our customers is really acceptable. We are underestimated.
So they want more.
Yeah, they want more and more. So we have developing this drone series into another level, 100 kilogram, and in this weight level, we have to make a lot of design changes, such as the structure. We are using a lot of carbon fiber materials.
Yes.
You have this.
And the detachable.
Yeah, probably most of the parts you can observe on the P100 is carbon fiber or carbon fiber mixed material. For the tube, it's pure carbon. And
so the advantage of this is more hard.
It is very rigid. It's rigid and have some flexibility. Well, the most important is that it is lightweighted. And you have to see that the main frame of P100, it is pure injected carbon. So it's motor injected. So you can't see any other companies or any other agriculture drone. They are using this kind of material and process to make this big, to make in this big,
Okay, so actually we all know that, as we just mentioned, that P100 is detachable design, right? So why you come up with this idea to do the detachable structure?
Detachable design is another very clear figure of the feature of this drone. I think it is because of one of our customers. They come to us when they come to us and said they are he was very angry about it because the drone was crushed in an
hard to disassembled.
Yeah, it was crushed and the stand of the drone was broken, but the main frame is also broken too because the chain effect. At that time, the stand is connected with the main frame.
So if you want to fix one, you need to
the fly system. Yes, that's why he was so angry about it. The local service center told him he need to wait about 2 to 3 days to get it fixed.
They are doing the operation in the field, they can't wait at all.
The working window is very short in China, and they are counting on those days to probably make the money for the whole year. So that it was very important for them. That's why they're so angry. So we
wanted to make them easier to do.
So after this, we started the full analysis of the past fly records, and we found out there are really some cases that the user broke the stand. Well, there is a chain effect that the mainframe of the main system is broken. So we thought at that time we should make some changes. That's the starting point of why we separate the payload system or the stand system with the main fly system. So the customers, if customers broke their stand or the payload system, what they need to do is swap up another one. So they doesn't need to be affected.
So thank you, Tian Hao, for sharing with us this detachable design. Mickey, could you share us the video of detachable design of P100 so that our audience can see what kind of it will be? Actually, this design is based on what we have do the survey on.
Yeah,
actually,
that-
the
that's-
customers have
that's one reason.
feedbacked.
Yeah,
Yeah.
that's one reason.
So we
Another
have
reason
considered
is that we can swatch different payload in between, a quick swap of different
we can change
payload.
into
Yeah,
different
the real
payload.
system and spray system, spread
Yeah.
system. Yeah.
Yes, and it will be more efficient actually, and very easier for you guys to
Yeah.
do the operation in
If
the
you
field.
you guys have a two payload system, you can do the work unstopped it, unstopped it. Yeah.
Yes.
So-
So why you come up this idea? Is there any story like you can share with us? You come up to do this separable
Yeah, this
design.
the separate design is the first reason is what I just mentioned.
Yeah.
Yeah.
You have
Because,
do the survey on, and you based
Yeah, we don't
on
want to break the
customers.
main system, even
Yeah.
though the stand is broken, even though the payload is broken, the drone can still working.
Yes, and if
That's
there-
very important. And
if there is
the second reason for that is for the continuous work. We can swap different payload system in between. And
I can see.
I believe the third one is good for transportation.
Yeah.
Do you know what I mean?
If you have a van.
Yeah. A van, you can separate it. Maybe put it on the top of the van.
Yes.
The fly system on the top, and then you put your payload system in the truck. Yeah.
Yeah, you can do very easy transportation. And when it comes to the spreading system, actually we have one here. Could you share with us some advantages of this spreading system?
Yeah, the Revo 3 system, I think it's the most revolutionary spray system. It combined with the three parts. I think the tank, which is the tank system, probably, and the feeding system, which you can see here, the school feeder system, and the spray system, the rotating disc. It's also common in other companies' product that they are having the same structure, the tank and the feeding system and the spray system, but they are usually in a top-down hierarchy. What do I mean top-down is the tank on the top, while a feeding window in the middle, and a spreading disc rotating parallel to the ground. If I can I draw it again? Yeah. So wipe it out.
Do we need a real case of this?
No. I believe I can draw it well. Okay. So in the common setup for spray system of any other companies or any other product, it's like the feeding tank is on the top, and the feeding window, the window here opens up and close to control the flow rate of those particles in the tank, right?
Yes.
And there will be a rotating disc down here to throw all those particles. Yeah. And this top-down hierarchy has a very obvious drawback. It's because the particles in the tank will stacking on each other, especially for sticky fertilizer or particles.
Yeah.
They tend to stick
to the wall.
Yeah, on the feeding window. So if you want to control the close and open of this window, it will be very hard, and this feeding system will usually get stuck because of the effect of gravity, because they are stacking on each other.
Yeah.
So we developed our Revo 3 system with a completely different setup or hierarchy. Is that, or if you look from the set wheel, we also have a tank system, but a school feeding system is actually parallel to the ground. So it's like here is a feeding system, and the particles is pushed by the screw feeder this way, along this way, and the rotating disc is here, right?
Yes.
So in this setup, even though these particles are stacking on each other and make this part sticky, we still can use this screw driving motor to push those particles toward
exclusive
yeah
to others.
toward the spray disc. And in this process, the screwdriver only need to conquer the static friction among those particles. So it will be less possible to get stuck compared with the traditional one.
More smoothly.
Yeah, it has a smooth feeding process.
Yeah. Okay. Thank you.
Yeah,
Actually, we have. Can you guys see on our background? We have actually 4 sizes of our screw feeders. Can we dismantle all of this to our audience?
Oh,
Yeah.
okay.
Let's show the 4.
This is a small screw feeder. It's used for seats reading.
Yeah.
Yeah, and we have bigger ones. Yeah.
Yeah. Could you
Okay. This one.
top 2?
And we designed a different size of screw feeder to meet different requirements of the particles. Yeah. So this is for seeds, and probably this is for fertilizer with bigger particle size. Yes. And you have noticed that there's a cut here, right?
Yeah.
Yeah.
There is a cut.
Every screwdriver there is a cut on the edge.
Okay. So can you see the cut on the screw feeder? So why we have this cut?
If you have a close look of this screw driving system, the screwdriver, there's a cut on this exactly on the edge. No matter what the screw feeder rotates, the cut will set is exactly at the edge. And this is because when the particles travel through edges, I mean this is a sharp edge. When particles travel through edges, they tend to get more friction and more easier to get stuck on these uneven edges. And so by making this cut, it will relieve the friction on the edge. So make sure that the travel of particles is smooth enough to cross those sharp edges.
Okay.
This is why we make the
cut on the
very
screw
little
feeder.
and yeah.
Yeah,
addressed
so
to-
we actually received the question from Vietnam. Is the fastener on the main frame broken or loosen easily?
The fastener, no, the fastener is designed with super strong durability, and we have tested. It has 4 to 5 times of payload it can hold. Then, I mean, it's really durable, and it's designed to maybe 4 to 5 times of durability. Yeah.
Yeah. So, is there any other questions? And so, why we have this auger like 2 or 2 rather 1? Is that because of
I think,
the uneven?
Yes.
direction?
Yes. Speaking of this, I have to talk about the spreading system or the spreading disc system. I have to compare the traditional one with our current one again. So the traditional one is a rotating disc that rotates parallel to the ground. And if you look from the top, the traditional one, will be a disc. This is the top wheel. The disc, and the particles will travel like in a circle area. And in this setup, the particle will throw by the disk, and there will be a velocity when when they throw the particle further away, and the particle will be affected by gravity. And this is very simple physics. If you throw something, there will be a trajectory like this, right? A trajectory like this. If you give this particle velocity, and it will travel like in this trajectory. So in the traditional rotating disk, this trajectory will only be affected by the gravity, which is the force at this direction, right? So you can guess if if the particle is in different size of different weight, it will have different trajectory. So that is not controlled by the disk itself. It only affected by gravity.
Yes.
If the particle is not even, the spray evenness cannot be guaranteed in this circle setup.
Yes.
Can you get that?
Yes.
Yeah.
It's only controlled by the
gravity.
Yes.
If it's a
by
bigger
gravity.
particle, it will travel
Directly drop.
a drop. And it is if it's a light one, probably it will travel further away from the disk.
Yes.
But in our setup, it is not it's a vertical disk. If you can see that,
Yes.
the disk is rotating vertically to the ground.
It is vertical, like
Yeah. So if you
directly into to the ground.
Revo 3, in Revo 3 setup, if you're looking from this spreading system from in the front, will be a rotating disk as well. But the spreading area is no longer a circle; it's a sector.
Yes.
It is a sector. And the particle that throw in this direction, right? This direction. And we can evaluate this trajectory again. Is the story different? Because the speed is at this direction, right? The speed is at this direction. And the gravity of this particle is at this direction. So this trajectory will still be affected by gravity, but much less, because the angle between these two vectors is much smaller than this one.
Yes.
That's why we can achieve the evenness of Revo 3 system.
Yeah.
So we were very confident to say that this is the most evenness system
the design
on the market.
Yeah.
Yes.
So actually, we can see Mickey. Can you show the video of the spreading system, and so that we can see when it.
So someone is asking questions.
Okay, the question: could you share the spreading rate of each spiral feeder? Can we say that?
I think we will have. We can get back to him and send him the
so
parameter.
we will collect this information,
have,
and please contact us later. We will send you this information. So, is there any other questions? So actually, after we have the V40 and the P100, the design details, we are actually very curious about the principles, like the philosophy when you do the design, like what kind of process it will be through, like a product from it do the design to the mass production, how many processes it will get through?
Yeah, I think for now, we will run about 3 productions for each product. In each production, we will test the drone and test the parts and to fly the drone itself. I mean, we are a team that working on the quality of the drone, and they stay in an airplane, in an airport. They fly those drone with the maximum fly speed and the maximum payload, and they constantly do the testing to maybe thousands times of real flight.
We can see the test area is just near our office. When you come to visit our company, you can see they are doing the testing.
Yeah, it's very noisy though.
So, and the next question that many our audience are curious about the logic and insights of our company to do the design of the whole products.
Yeah, I think the insight of the principle of designing things for us is to stay in the first principle. What do I mean is we have to consider a question or problem within the constraint of probably Newton's first, second, and third law. And I think this is very basic philosophy that we want to follow, to seek the very root of the question and to see what our customers really need and to solve those problems from the very basic theory.
And from the real case, and we got some experience, and we will do some change on our design.
Yes, that's right.
Okay, so do you have any other plan, like what do you think about the future of the design on our product, or even the whole industry? Okay,
I believe that the agriculture drone can definitely develop to another stage. Like it is like a car or something. The car it has a very long durability and long lifetime, and all you need to do is to go to a service center and this drone this drone is just like a stable car, a commercial car that we saw on the market. It is very productive. Well, if you buy it, you can sell it as well, and it has a very healthy market flow for those kind of product. This is what we are chasing.
Yeah, we are trying to do that. That's quite a brave thinking. Let's expect that. Okay, so if you have any questions, please leave your comment here. And if there are any other topic that you are interested, you can just leave your messages here and in our Facebook group. So actually, in the beginning, we don't have voice. We have some voice problems. So let me introduce Tian Hao again.
Okay.
So I'm Yasmin. So welcome to Gyro Talk. Amro cannot join up this live today because of some sudden reason, and he will meet you guys in the next time. And Tian Hao is our chief designer of our company. Yeah, welcome Tian Hao, and thank you for joining us.
That's weird.
And thank you to answering all these questions and share some insights and some inspirations on the design of XAG. If you still have some questions or something you are, if you are interested, please leave that in our comment now or later in our Facebook group. So thank you for joining us today, and follow up in our Facebook group and subscribe our channel. Welcome to today's live, and see you next time. Bye.